and 0. So we have -4, -3, -2, -1, 0, 1, 2, 3 to infinity. Okay, but also we don't have fraction. For example, 1 over 2, 0.2. This is not in integer, not in whole number, not in natural number. Okay, look at this three sets. Three sets, for example, we can put it like this: 6 over 2. 6 over 2 denote this is belongs to the natural number, yes or no? 6 over 2. This is included in natural number, yes or no? Yes. Why? Because 6 over 2, this is equal what? This is equal 3. So 3 in natural number. Okay. So if we have the fraction, you must simplify the fraction. After that, you can decision this is in or out the natural number or whole number or integer number. Okay. Now we can conclude also that n, this is subset from W, and this is subset from Z. What's the meaning subset? Subset means all items in N also in W. All items in W also in Z. يعني نعني بالسبست انه كل عناصر N موجودة في ال W وال W كل عناصرها موجود في ال Z. Okay. Now, if we have also radical, for example, 25, this is belongs to that W, yes or no? Radical 25, this equal 5. So this is in W also, okay? But if we have, for example, 3 over 4, this is belongs to Z. No. Why? Because 3 over 4, this after simplify, this is not integer number. Okay, so this is not belongs to the Z. Okay, this is 0.75 Godwin. Now, also we have rational number. What's the meaning rational number? Rational numbers means any number can put it as numerator over denominator. أي عدد ممكن كتابته على صورة وسط ومقام فهو rational number. Okay. For example, 3 over 4, this is rational number. This is Q. Rational number denoted by Q. Okay. In all books of the mathematics or reference, and this is natural. W, this is for whole. Z for integer. Q for rational. Okay, in all reference of mathematics. Now 3 over 4, this is belongs to the rational number. So 3 over 4 belongs to the Q. Now I ask you about the for example 4. This is belongs to the Q, yes or no? 4. أيمن، أميرة، وليد، رقية، كله يس. ما في أحد نو. أثير نو. خالد شور، متأكد. طيب. So this is yes, correct. 4 belongs to the Q. Why? Why أميرة? Why وليد? Why أيمن? Why Khalid? Sadim? Why 4 belongs to the Q? We can write the 4 as fraction. For example, 4 over 1, good. We can put it as 12 over 3. We can put it 8 over 2. So we can put it as a fraction, B over Q, numerator over denominator. But This is the integer number, and this is integer number. This is belongs to the Q, 5/0. No. Why? This is we have condition, or main condition in denominators must be not equal 0. The denominator maqam must be not equal 0. Okay, so this is not belongs to the Q. Now we have some decimal number. Some decimal number belongs to the Q. If we have decimal numbers, no, if we have a finite decimal number, for example, 5.4, this is belongs to the Q, because we can write 5.4 as 54/10. Okay. Also 0.3552, this is belongs to the Q. Why? We can put it 3552/1000. Okay. Also we have repeating decimal number, repeating to infinity. For example, 0.333. Sorry, where is dot? Wait, 0.3333. This is repeating to infinity. This is also belongs to the Q. Why? This is 1/3. 1/3 equals 0.3333. So we can put it the repeating number as a fraction, numerator over denominators. Okay. We can denote it by 0.333. We can simplify like this, 0.3, and put it the line above the number already repeating to infinity. So 3 repeating to infinity, we can put it 1/3 and line above the 3. This is mean 3 repeating to infinity. Okay. Now we have irrational number. Irrational number, this is number cannot be put it as numerator over denominator. هنا الirrational number أعداد غير نسبية بنسميها rational نسبي، irrational غير نسبي، وهي لا يمكن كتابتها على صورة وسط ومقام. الآن irrational number denoted by H. For example, for irrational number, أعطوني for example, give me for example for irrational number. Cannot put it as A over B or B over Q. Give me example for irrational number. By good. By irrational number. I complex. This is not the set in this I complex number, not rational number. 3.4, this is rational. Ayman, 3.14, this is rational number. Okay. Maybe some books use the 3.14 as approximate for by, but by, this is repeating random after decimal sign. We have many numbers randomly to infinity. Okay. E, good. Natural. No, by not 3.14. This is in a book in the يعني schools خلينا نحكي, some school or some book in the secondary or using 3.14, but by not, you can use the calculator, put it the by, this is not 3.14. okay. Roots of 2 not over. سارة الجذور كتبت مش كل الجذور, not all of the roots. okay? Because the radical 25, this is 5, this is natural, this is integer, okay? So radical 2, this is irrational, good. Radical 3, this is irrational. Radical 5, this is irrational, okay? So this is the irrational number. Also, if you have, for example, 2.31152798112, this is random after decimal sign. بعد إشارة الديسيمال we have random number to infinity. So this is irrational number. Okay, if we have random number, لاحظ random number يعني أرقام عشوائية مش repeating مش متكرر. Okay, this is repeating, this is random يعني عشوائي. To infinity بتظل ماشي infinity, this is irrational number. Okay, now what's the meaning absolute value? We need a new slide, blank slide, wait. Absolute value. Absolute value denoted by two lines around the number or the expression. For example, the absolute value of the 5 equal 5. Absolute value la negative 5, this is equal what? 5. So the absolute value remove the what? Remove, if we have negative sign, remove the negative. Okay, هذه بنسميها القيمة المطلقة. نعم. But the absolute value of the 0, 0, still 0. Okay, positive, positive, 0, 0. But if we have negative, so this is equal, must be converted to positive. Okay, but some students have confused for, look at this, negative 2. This is equal what? أميرة، رقية، كليات، بتول، بطلت أجمع، فاطمة، روبا، طوبة، سارة، أحمد، بيان، كلهم نيجاتيف 2 ما عدا سارة ورنيم. طيب هذه equal negative 2. Why negative 2? This is not negative equal positive. This is if we have the brackets إذا كان عندنا أقواس عادية negative equal to, okay, this is good. But if we have absolute value, we cannot put it any outside number, negative, addition, subtraction, multiplication inside the what? Absolute value. Okay, so you must implement the absolute value and find the value of absolute value. After that, you can multiply anything outside, multiply, addition, subtraction outside the absolute value. Okay, so we have negative for what? For this outside absolute value, and the absolute value equal what? Absolute value for negative 2 equal 2. So we have what? Negative 2. Okay, ما في شيء بيأثر على القيمة المطلقة، ما في شيء بيأثر من برا. أول شيء ننفذ ما داخل القيمة المطلقة. Also look at this, if we have 5 minus 8, 5 minus 8, firstly implement inside the absolute value. So we have 5 minus 8, negative 3. The negative 3 with absolute value equal what? 3. Okay. Now, negative 3, but it will be 3. Good, Walid. Now, the real line, what's the meaning real line? This is the line from negative infinity to infinity. We have 0, 1, 2, 3, negative 1, negative 2, negative 3, and so on. Okay, to infinity to minus infinity. This is the real line. If we need to compute the distance between any point on the real line, we can use the distance between A and B on the real line equal what? Distance absolute value A minus B, or equal absolute value B minus A. We can use A minus B or B minus A. Why this is equal? Look at this. If we have 5 minus 8 equal negative 3 with the absolute value equal 3. Also, if we have 8 minus 5, this is equal what? This is equal 3 with absolute value also 3. So, in absolute value, if we have A minus B or B minus A inside absolute value, this is equal, already equal. So, what's the distance between A, this is A, and this is B? What's the distance between A and B? The distance between A and B, A equal negative 3, B equal 2. So the distance equal minus 3 minus 2. So we have absolute value for negative 5, and this is equal what? Equal 5. Okay, equal 5. Sarah, Amira, minus 3 minus 2, but with absolute value. Okay, Walid. Sarah 1, this is incorrect. Okay, with absolute value, this is the distance. Look at this. We have 1, 2, 3, 4, 5. So the distance from A to B equal 5. But if we have long numbers, for example, what's the distance between minus 102 with B, for example, 351. So you cannot use the real line. You must use the formula. Formula of the distance on the line. This is absolute value A minus B or B minus A. Okay, use the formula. Any question? Okay, look at this example for the real line set. Look at this. 2 over 3, this is belong to what? To Q. Okay. Look at this. Minus 2 belongs to natural number. No, this is not belong to the natural number. So minus 2 belongs to what? Minus 2 belongs to what? Z. Good. Also belongs to Z to R, real number. Okay. Q. Good. Integer. Now, so minus 2 minus 2 belongs to the Q, minus 2 belongs to the Z, also minus 2 belongs to R. R means real number. Real numbers contain all numbers, natural, rational and irrational number. So R, this is rational number, union, irrational number. Okay, Q and H. Some books put the irrational number I, not H. But this is irrational number. Rational number and irrational number, this is equal R. Real number. Look at this. This is correct or incorrect? Z subset of Q. This is correct or not correct? Yes, yes, good. Because all integer number, we can put it as a fraction, A over B. Any number, 5, 2, minus 2, minus 3, 0, also 0, yes, also 0, because 0 over 3, this is belongs to Z and belongs to also the Q, 0 over 3. This is no problem, 0 over 3, because 0 over 3 equal what? 0. But 3 over 0, this is not belongs to the Q. Okay? 0 in denominators, this is undefined. But in numerator, this is defined, equal 0. 0 over 3, 0. So Z subset from Q, yes, this is correct. Look at this example also. This is mean, set builder and inequality. This is graph of the line, and this is the intervals. Okay. Before solving this example, we must take the difference between inequality and real line and interval. Any integer, any set of real number, we cannot put it as the set, and we cannot write the real numbers between 0 and 1. For example, if I ask you about give me all real number from 0 to 1 or from 0 to 2. You can write all numbers from 0 to 2 or real number? No. So how can put it, or how can describe about this the set of numbers? Okay, we use one of them, real number or integer, real number or interval or inequality. Interval, real line, inequality. We have 8 intervals. The first 4 intervals like this, from A to B, from A to B, from A to B, from A to B. This is 4 intervals. The difference between them, just the brackets. We have brackets and we have brackets close or open. Okay, this is called open. This is closed brackets. Okay, and what's the meaning open and close? For example, if we have 2 and 5, this is open, this is closed. What's the meaning open from 2, close from 5? This means 2 not belong to this interval. So start after 2. Start after 2. But 5 in the interval. So we finished in the 5 Okay, so start not from 2, after 2, but stop or finish at 5. Okay, so for example, 2 not belongs, but 2.000000001, this is belongs to the 1 and 5. Sorry, 2 and 5. Look at this. Any number after 5, after 2, this is belongs to the open from 2, close from 5. Okay, but close from 5, the 5 included in interval. Now, how can describe that by real line? By real line, we put the real line from negative infinity to infinity, from A to B, and hashing from A to B, open on A, close, also open on B, because A and B not included in this interval. Okay, how can describe that by inequality? Inequality, look at this. This is the X, the hashing region. This is the X. X greater than A, X greater than A, less than B. And we cannot here put it greater than or equal, or less than or equal. Why? Because this is the open. We cannot equal. If we put it equal, so A included in the interval, but this is A in open interval, open side, so not included. So remove the equal. Look at the second interval. This is different on what? Or only on A. Close in A, open in B, and hashing between them. So this is the region from A and open on B. Okay, and the inequality, this is greater than or equal A, less than B. Why put it equal between X and A? Because A closed, A included an interval. Okay, now the third one, from negative infinity to infinity, from A to B, and hashing. So this is X greater than A but less than or equal B. The last one, from minus infinity to infinity, close from A, close from B, hashing between them. Okay, so we have equality on A and B. This is the first 4 interval. We have another 4. Okay, look at this. We have also the half interval. Half interval means we have from negative infinity to A, from negative infinity to A and close from A open to infinity, from A close to infinity. Always the side of infinity or my negative infinity always open. Okay, we cannot put it the close because this is not specific number. Okay, now from minus infinity to infinity, and we have open at A, the hashing from negative infinity to A. From negative infinity to infinity at A, hashing from negative infinity to A. Here, from negative infinity to infinity, open A, hashing from A to infinity. Here, A included, so close at A, hashing to infinity. Now, look at this, the region of hashing. This is the X. So X greater than or less than X less than LA. Any number less than A. Okay. from minus infinity to a, this is less than a. If we have closed, so put it less than or equal a. Look at this here. X greater than or less than? Greater than a. So x greater than a and x greater than or equal a. Okay. Now go to the example number 2. Look at this inequality. X less than 3. Less than 3 from 3 and infinity to infinity. We can put it open or like this. This is mean open. Okay. Look at the interval. Interval from minus infinity to 3. Open from 3. Look at the second inequality from minus 2 to 5. X between minus 2 and 5. X greater than minus 2. Greater than minus 2 without equal, so this is open. Look at this, open. We can put it like this or open brackets. To 5, this means 5 closed. We can put it like this or like this. Okay, this is the 5. So we have interval open from minus 2, closed from 5, from minus 2 to 5. Any question about example number 2? Okay. Example number 3, look at this. We need to find the value without absolute value. Look at this. Before solving the example 3, look at this side. If we have 2 minus 5 and we need to remove the absolute value. If we need to remove absolute value, we must put it negative if we must multiply inside the absolute value with negative if the inside absolute value equal negative. Okay, so how can remove the absolute value? Remove the absolute value, look at the inside the absolute value. This is negative, so we must multiply by negative to convert to positive. If inside the absolute value positive, so just remove the absolute value and this is equal 3, the same. But if we have inside the absolute value negative and you need to remove the absolute value sign, you must multiply with negative. So look at this. This is negative 2 minus 5. This is negative minus 3. If we need to remove the absolute value, so this is equal negative 2 minus 5. We must multiply inside the absolute value by negative. Look at this. We have negative 3. So this is equal 3. Okay. Now 2 minus radical 7. Radical 7, this is greater than 2. So 2 minus radical 7, this is negative. Okay, because radical 4 equal 2. Radical 7 greater than 2. So 2 minus radical 7, this is negative. Negative. If we need to remove the absolute value, we must multiply by what? By negative. So negative multiply 2, negative multiply negative 7. So we have radical 7 minus 2. Okay. What's the distance between 6 and negative 4? Look at this. This is the A. This is the B. Okay. What's the distance between 6 and negative 4? Put it 6, minus -4, negative equal positive. So we have 6 plus 4 equal what? 10. Like this. If we put it -4 minus 6, this is -10. -10 with absolute value equal what? Equal 10 also. So this is the same. Look at this example 5. We need to simplify. Simplify. Firstly, the order of the operators. خلينا نحكي ترتيب الأوردر للأوبريتورز العمليات. أول شيء الراديكال or البراكتس. هذا أول شيء من نفذه radical or brackets. After that الإكسبوننت. If we have exponent الأسس. After that multiplication and division. After that addition and subtraction. أضعف إشي الاديشن والسبتراكشن. أضعف إشي. If we have all operators addition and subtraction, so start from left to right. From left to right. إذا كله جمع وطرح نبدأ من اليسار لليمين حسب الأولوية وحسب ظهورها. لكن الترتيب أول شيء البراكتس الراديكال. After that الإكسبوننت الاديشن multiplication division. After that the last one addition and subtraction. So look at this. This is the brackets. Inside the brackets 5 minus 8 equal -3. Look at this. Inside the roots we have exponent inside the roots. We cannot find the subtract. We have exponent. So exponent, this is the, look at this, second order. So we need to find 5 squared 25 and 4 squared equal 16. After that continue. The subtract 25 and 16, this is equal what? 9. And the square الإكسبوننت هذا -2 square equal what? Equal 9. -3 sorry, square equal 9. Now we need to find the radical, the multiplication. Look at this, we have subtract but cannot find the subtract. We must finish all exponent, radical, multiplication, division. After that, last one, addition and subtraction. Look at this. Start from left to right. 12 minus 18 equal -6. -6 plus 3 equal -3. Like this. Okay, any question? This is the summary of the set of numbers, just summary, real number, denoted by R. The real number contain the rational number and irrational number, the yellow and green, this is all union between the green and yellow, rational, irrational, this is equal real number, okay? Inside the rational number we have integer. For example, -1, -2, -3, 0, 1, 2, 3. Inside the integer we have whole numbers like 0, 1, 2, 3. Inside the whole numbers we have natural number, for example 1, 2, 3, 4 and so on to infinity. Okay, look at this is the example of irrational number by E radical 19 0.505005. So this is not repeating. Okay, now the properties of real numbers. We have many properties. The main properties is commutative. Commutative means in the real number, if we put it 5 plus commutative addition, Okay, commutative addition. 5 plus 2 equal to plus 5. This is not different, okay, in addition. So we commutative addition, this is means 5 plus 2 equal to plus 5, or A plus B equal B plus A. Commutative also we have for multiplication, okay. For multiplication we can find the 3 multiply 4, and this is equal 4 multiply 3. This is the same. But we cannot we don't have the commutative for subtract, because 5 minus 2 not equal to minus 5. Okay, this is in absolute value or are equal, but in the real number 5 minus 2, this is not equal to minus 5. Also for division للقسمة. Now associative for addition. Please close your mic, please. The associative for addition, if we have 3 numbers, we cannot find the addition together. Already used, we can find the addition for 2, after that the result at the third number. Okay, so we can arrange the numbers, so we can find the addition for the first 2 numbers, or last 2 numbers, or the first with last, middle with the second, and so on. Okay, so if we have 3 plus 5 plus 7, we can find 3 plus 5, after that add to 7, or we can find the addition 5 with 7, after that the result add to the 3. This is equal. Okay, also in multiplication, associative in multiplication, if we have 3 numbers, we can multiply the first 2 number, the last 2 number, the middle with the previous, and or the next number, like this. Okay, identity for addition. Identity for addition, this is the 0. This is mean we have number like 0. This is add for any numbers without change the value. Without change the value of the numbers. So A plus 0 equal 0 plus A, and this is equal A. So 5 plus 0, this is equal 0 plus 5, and this is equal the same number. This is equal the 5. Okay. Also we have identity for multiplication. Multiplication identity 1, but in addition 0, because 1 in multiplication, this is not change the value of number. So 1 multiply 2, this is equal to multiply 1, and this is equal 2. Okay. The inverse, we have inverse for addition and multiplication. For addition, if we have 5, the inverse minus 5. If we have minus 2, the inverse equal what? 2. This is the inverse. So the inverse, this is if we have negative, the inverse positive. If we have positive, the inverse addition, this is negative. Okay, but in multiplication inverse, this is equal, replace numerator with denominators. Okay, swap between them. So if we have 5, the inverse in multiplication, this is 1 over 5. If we have 1 over 2, the inverse equal 2. If we have 3 over 5, the inverse 5 over 3. So the inverse swap between numerators and denominators. Okay. The last one, distribution, multiplication on addition, like this. If we have any number, for example, 2 multiply with A plus X, we can multiply 2 with A and replace A with any number, for example 4, We can multiply 2 with 4, this is 8, plus, and multiply 2 with x, this is 2x. Okay, this is the distribution, multiplication on addition. Addition or subtraction, this is no problem. We can multiply negative number with the brackets, positive number with the brackets, and inside the brackets addition, subtraction, this is no problem. This is just if we need to build the formula. For example, in the province of Saskatchewan and Canada, an individual catch speeding between 31 and 50 kilometers inclusive over the limit would be 70. Okay, plus what? $2 for every kilometer over the posted limit. Okay. هنا بتحدث عن يعني انه بدنا نكون فورمولا للكوست لمخالفة معينة. اوكي، فاذا تجاوزت السرعة راح يكون في عندك 70، هذه المخالفة $70 plus what? $2 for every kilometer over the limit. راح يكون في عندك الفيز اللي بدك تدفعه $2 لكل كيلومتر فوق الليمت تبعك. فالاكس هنا اللي هي خلينا نحكي كم كيلومتر انت تجاوزت. هنا مثلا بقول لي use the model اللي هو الكوست تبعنا، هذا اللي حسبناه. An example 1 to determine the cost of speeding ticket for the individual traveling 40 over the posted limit. اوكي، اذا هذا اللي راح يكون x، نضيفه بدل x ونحسب الكوست تبعنا. عندي 40 كيلومتر over the posted speed limit. احنا قلنا راح تدفع 70 plus each kilometer the cost equal $2. So we have 2 multiply 40, we have 80, so we have 150. So this is just substitute the 40 with unknown x. We have properties for exponent. Exponent, if we have 0 exponent, and b to the power 0, this is directly equal what? 1. What's the meaning exponent? For example, what's the meaning? For example, 2 to the power 4. This is not 2 multiply 4. This is 2 multiply 2 multiply 2 multiply 2. So this is equal 16. Okay. So 2 to the power n, this is the 2 multiply itself with n times. Okay. So if we have negative, we can convert the negative exponent to positive by putting the base and exponent of the base in numerators, from numerator to denominators. For example, if we have 2 to the power negative 3, this is equal 1 over 2 to the power 3, and this is equal 1 over 8. So 2 to the power negative 3, this is equal 1 over 8. Okay. If we have product, the same base, this is the base, this is base, and this is exponent. هذا exponent، هذا البيس، الأساس والأس. If we have the same base but different exponent, so in multiplication we can add the exponent. For example, x to the power 2 multiply x to the power 3, this is equal x to the power 5. 2 plus 3, 2 plus 3. In fraction, if we have the same base with different exponent MON, so subtract the exponent in numerators minus denominators. For example, if we have x to the power 5 over x to the power 2, this equal 5, x to the power 5 minus 2, this is equal x to the power 3. Power to the power, if we have two exponent of exponent, okay? So we can multiply the exponent together. For example, x squared to the power 4, this equal x to the power 8. Why? Because multiply exponent 2 with exponent 4. 2 multiply 4 equal 8. Power of a product. If we have power for product A multiply B, we can distribute the product on A and B. So this is equal A to the power M or B to the power M. For example, if we have 3x to the power 3, we can, or 2. This is, we can distribute the exponent 2 on the 3 and x. So we have 3 squared multiply x squared. So we have 9x squared, like this. Okay. The power of quotient, we can distribute also the exponent on the numerators and denominators. For example, if we have x to the power 3 over 2 to the power 4, this equal x to the power 3 all to the power 4 over 2 to the power 4, and this is equal x to the power, this is exponent to exponent, so multiply 3 with 4 equal 12, x to the power 12 over 2 to the power 4 equal 16, like this. Look at this, the expression. This is called scientific notation. Scientific notation means number multiplied by 10 to the power n. But A, this is A, absolute value of A, greater than or equal 1, less than or equal, less than 10. So must be 1.1.29 point, not 2-digit point. Okay, so look at this. For example, this is scientific notation. If we put it 5, this is scientific notation. Please close your mic. This is scientific notation, 52.1 multiply 10 to the power 4. No. Why no? Because this is, look at this, this is not between 1 and 10. This is 52. So we need to convert it 5.21 multiply 10 to the power 5, like this. Okay. Also 0.21 multiply 10 to the power 3. This is scientific notation? No, because before the decimal sign this is 0. We need to A, this is A, must be between 1 and 10. So we can rewrite this one, 2.1 multiply 10 to the power 2, like this. We move the decimal to the right. So decrease the power. If we move the decimal to the left, increase the power. Okay. Any question? Any question? تحدثنا عنها, not recorded. We have already recorded lecture and inshallah posted on LMS, but this lecture not recorded. مين كمان? Yes, محمد مهند عندك سؤال يس يعني خلاص اسأل مباشر. اوكي مهند can you repeat the power of the quotient؟ اي واحد هذا انت قصدك. If we have the exponent we can distribute the exponent in numerators and denominators. Okay, another example. Wait. Another example, look at this. If we have 5x to the power 3 over مثلا y and all to the power 2. We can distribute the 2 in numerators and denominators. So we can distribute the 2 in 5x to the power 3 all square. Okay, and distribute the square also in denominators. Okay, now also we can distribute the 2 in 5 and x because this is the multiplication, so we can distribute the exponent in multiplication and quotient. This equal 5 square and x to the power 3 all square over y square, but 5 square equal 25. We have exponent to exponent, so multiply 3 with 2, so we have x to the power what? 6 over y square. Okay, okay. ميرا بتسأل عن ال last point I think for decimal. ميرا for sorry scientific notation. Okay, scientific notation must be a multiply 10 to the power n, but a from 1 to 10, from 1 to 10, not greater than 10, greater than or equal 10, not less than 1. Okay, for example, if we have 0.532 multiply 10 to the power 7, this equal, this is scientific notation? No. Why? This is less than 1. We have 0.5, not this is number not greater than 1. Okay, so we move the decimal to the right, so we have 5.32 multiplied by 10 to the power what? When move the decimal to the right, increase or decrease? Decrease the power, so decrease by 1. Good. Okay, look at this. If we have 256.31 multiplied by 10 to the power 11, this is scientific notation? No. Why? Because this is greater than 10. So we can rewrite by move the decimal 2 times. Okay, 2 digit. So we have 2.5631. We already moved the sign decimal 2 digit to what? To the left. So this is equal 10 to the power what? Increase by 2 or decrease by 2? Not by 1. Muhammad, we move 2. 13, good. So this is increase, not decrease, increase. Look at this decimal 4, هذا الديسيمال to the left increasing. Increasing يعني بنزيد. إذا كان عندي الديسيمال وحركناه ناحية الرايت هذا decreasing بتناقص. اوكي وضحت؟ وحسب الديجيت اللي بتحرك 1 digit 2 digit 3 digit move to left to right. So this is we can decide how many new power of the 10 exponent of the 10. Any question? Look at this. Any brackets to the power 0 equal what? 1. Any brackets. For example, if we have 10 to the power 12 multiply x to the power 3 y multiply 15, all of this to the power 0, this is equal what? 1. Okay. If we have negative, so put it the base and exponent in the denominators. Okay. Now, example for multiplication, look at this. This is example for multiplication. Multiplication means if we have x to the power and multiply x to the power, so we must add the exponent. 7 plus minus 2, this is equal what? X to the power 5. طيب نرجع للسلايد. انتهينا. نيجي للكوشنت. الكوشنت بدنا نطرح. فمثلا عندي أنا هنا z to the power 9 over z to the power 5. So 9 minus 5 equal z to the power 4. Exponent of exponent, for example, minus 2 to exponent 4, multiply the exponent. Minus 2 multiply 4 minus 8. So we have y to the power minus 8, or we can put it the y to the power minus 8 in denominators and become 1 over y to the power 8. This is example to distribute the exponent on the product. We can distribute the exponent 4 on 2 and x. So we have 2 to the power 4 multiply x to the power 4. 2 to the power 4 equals 16. So we have 16 multiply x to the power 4. If we have the quotient, we can distribute the quotient in numerator and denominators like this. So for example, we can distribute the 3 on 5 and in x square. 5 to the power 3 equal 125. We have power to the power or exponent for exponent. So multiply 2 multiply 3 equal 6. So we have 125 over x to the power 6. Okay. This is the scientific notation example. Look at this number. We have, this is not decimal. If we put it 5, 4, and this is not decimal. Okay. هذه مو decimal، ما تعتبر decimal. decimal وين؟ نقطة. dot. This is the decimal. هذه decimal sign. اوكي. اما هذه لا، هذه تعتبر انه فاصل بين المئات والالوف والملايين والى اخره. اذا بدنا نحرك move the decimal 1 2 3 4 فقط بنخلي 1 digit. So this is 5.4 10 to the power 4 لأنه حركناها ناحية to the left. So increase the power. So we have 10 to the power 4. Okay. أروى إيش الفرق؟ هذه فقط فاصلة، يعني مش ضروري تنكتب، يعني هذه هي نفسها 54,000 فقط. هذه الفاصلة هي تفرقة ما بين خانات المئات والآلاف يعني مثلا لو عندنا على سبيل المثال لسه 6 وبعديها فقط عشان نفرق إنه هون في عندي مليون thousands hundreds and tens and ones. اوكي، بس فقط تساعد على القراءة مثل ما قالت لنا. اما هي مو فاصلة، الفاصلة في الانجليزي هي دوت. اوكي، ما ننخدع، هذه فقط يعني لاحظي هذه الدوت، هذه الديسيمال. شوف الديسيمال كيف شكلها، هذه الديسيمال، لكن هذه هاي خليني امسح اعمل زوم. واضح، في فرق. تمام. طيب مثال الثاني هنا، the second one. Look at this. This is the decimal. Okay, we move 1 2 3 4 5 6 7 8 9 10. So here 5.68. 10 هي أصلا كانت 10 to the power 0، يعني هي هذا العدد. يعني لما يكون عندي 0.000000 مثلا 52 for example, this equal 5.2 and move the 1 2 3 4 5 6 7. So 10 to the power negative 7. طب ليه negative 7؟ لأنه هذه multiply 10 to the power 0. 10 to the power 0 1 يعني كأنه مش موجود. multiply by 1 this is ignore. صح؟ طيب نقص من الزيرو 7 فأصبحت نيجاتيف 7. Okay, so here we don't have any multiply by 10. So after move, if we have a move to the right, so this is the negative. Move to the right 5 digit, so this is 10 to the power negative 5. We don't have 5 to the power, for example, 12 and 12 minus 5 equal مثلا 7. Here we don't have 10 to the power anything. Okay, so this is direct 10 to the power negative 5, for example. Look at this. This is in decimal, in scientific notation. This is the same. Multiply by 10 to the power 0. We no need to move the decimal from left or to right, because we have, this is the number from 1 to 10. 8.75, this is from 1 to 10. Look at this. This is to scientific notation. After multiplication, 2.5 with 6, this is equal what? 15. And multiply 10 with 10, this is 10 to the power 11. Like this, 10 to the power 11. Now, this is scientific, not scientific, because this is greater than 10. So we need to move the one digit to the left, so increase the power. 1.5 10 to the power 1, or directly 1.5 10 to the power 12, because it increase one. If we don't have any decimal, for example 5 2 3 4, this is mean in scientific, this is here the decimal. Okay, here the decimal, we can remove this decimal sign. In scientific, this is 5.234. So how many digits move to the left? 3 digits. This is decimal 1 2 3. So this is 10 to the power 3. Any question? Any question? Okay. Now the rational exponent. Rational exponent, this means in the power we have the fraction. For example, 5 to the power 1 over 2 or 6 to the power 2 over 3, like this. So if we have the fraction in exponent, so this is the radical. Okay, look at this. If we have b to the power n equal a, so this means the b is the nth root of a. Look at this in the numbers. For example, 5 square equal 25. This means the second root of 25 equal what? Equal 5. The second root of the 25, the second root of the 25 equal what? Equal 5. Okay. Another example, 2 to the power 3 equal 8. The third root, put it the 3 here, put it the 2 here, okay? Of the 8 equal what? Equal 2. So, the third root of 8 equal 2. The second root, this called square roots, okay? The third root, cube roots, okay? All of this called radical. This is the radical, الجذور. Now, look at this. If we have radical of the nth root, a with nth root, this is equal a 1 over n, fraction in exponent, fraction. For example, 4, this equal 4 1 over 3. 4 to the power 1 over 3. The third root of the 4, this is equal 4 to the power 1 over 3. Sometimes we have m over n. M over n, we can put it, this is as roots, n, and m inside the roots or outside the roots, like this. So, for example, 4, 3 over 2, we can put it like this, rewrite this one in the radical. This is the second root, for what? For 4, all of to the power 3, or we can put the second roots of the 4 to the power 3. So we can put it the 3 as the exponent of the radical or exponent inside the radical. Okay? This is the same value. Look at this. How can calculate this one? The square roots of the 4 equal 2. 2 to the power 4 equal what? 8. Like this. Also, we can use 4 to the power 3. This is 64. Radical for 64 equal 8. So this is the same value. Sometimes we have the roots and the exponent of the a are the same. Yani radical n, and inside the radical a to the power n. N, if n is even, so this is equal a, absolute value of a. But if odd, this is equal a only without absolute value. For example, if we have radical 4 and we have 5 to the power 4, okay, this is equal 5. If we have negative, this equal also 5, because this is the absolute value. this is 5, this is 5, because the radical with index 4 and the power of 5 4. Okay, this is even زوجي, so we must remove the exponent with the radical but put it the absolute value. But if we have odd, for example 3 5 to the power 3, remove 3 with 3, this is equal 5. And if we have negative, remove 3 with 3, put it negative 5 without absolute value, because this is the odd. Okay. Now the product of radicals, quotient of radicals, we need a radical of radical. Inside the radical we need more slide, blank slide. Look at this. Product of the two roots. If we have roots with the same, like this, look at this, the same index, we can put it as one root. For example, radical of x multiply radical of 2 multiply by radical of x square, this equal, or x to the power 3, this equal what? This, we can put it as one radical because this is the same, square root, square root, square root. Put it x multiply 2 multiply x to the power 3, and we have 2x, we can put it x to the power 4, like this. Okay. And we can simplify this one by radical 2 with x square. This equal radical 2 and radical x to the power 4. If we need to doing more simplify, this equal radical 2 and this equal x square. Why this is equal x square? Because this equal 4 over 2. 4 over what? The index 2. We use the x to the power m over n. This is equal x m over n. M over n. Okay. If we have quotient, for example, 6 x to the power 5 over 2x square, like this. We can put it as one root, and we have 6x to the power 5 over 2x square. Now after simplify, 6 over 2 3, and x to the power 5 over x to the power 2, this is x to the power 3, because subtract 5 minus 2, so we have x to the power 3. Now we can distribute the radical on 3 and on x to the power 3, but x to the power 3 inside the third root, this equal x, so we have x. Okay. Root inside the roots, we can multiply the two roots. For example, look at this. We have root m, inside we have root n, and so on. So this is root and multiply two roots, two nth roots, okay? For example, if you have 3x, radical x, like this. This equal x, but we have 2 multiply 3, this equal 6, like this. So we have 6 roots of the x. 6 root. 6 root of the x, this is we calculated by 2 multiply 3. 2, this is the index of the square root. 3, this is the third root of this radical. 2 multiply 6. For example, if we have 4 and 3, this equal what? Multiply this root with this root, because we have root inside the roots. Okay, so this is equal to 12. Yes. Good. This is example. 7 is the square root of 49, because we have square roots. So 7 to the power 2 equal what? 49. 7 to the power 2 equal 4. Also, minus 7 to the power 2 equal what? Also 49. Now, radical for 49 equal 7. Radical, always the radical equal positive. Radical for 25, for 4, for 0, for 1. Always radical, the value of the radical 0 or positive. Cannot put it the radical equal negative. Okay? Always the result of radical equal positive. Square roots, square roots. Look at this. This is equal what? The third root of minus 64. And this is equal minus 4. Why? Because this is minus 4 to the power 3. Minus 4 to the power 3, this is negative 64. Remove 3 with 3, so we have negative 4. Odd, yes, good. Look at this. If we have negative inside the root, this is not real number. Not real number. Not real number. لا ينتمي إلى الR. Not belongs to R. Inside the root negative, and we have the root even, this is not real number. If we have odd, if we have odd, so this is equal, maybe positive or negative. This is depend inside the roots. Look at this. This is mean the third root and the roots to the power 2. The third root of 125, this is equal 5. 5 square equal 25. So 125 to the power 2 over 3 equal 25. If we need to find the simplify of this expression, first we multiply by between x. This is equal 1 over 5 plus 2 over 5, because in the multiplication or in the product we addition the exponent. So 1 over 5 plus 2 over 5, this is equal 3 over 5. 3 over 5. And we have 4 over 5. Subtract the 2 exponent. So we have negative 1 over 5. Now we have exponent to exponent. Multiply minus 1 over 5 with 10. This equal minus 2. Minus 2, if we need to convert the exponent from negative to positive, so put the exponent and base and exponent in the denominators. So we have 1 over x squared. 1 over x squared. Now,
can this example?
For what?
Example 3.
Okay. Okay, I put it another example for this. Okay. Oops. And if we have two variable, for example, x to the power 5 over 3 multiply multiply y to the power 4 over x to the power 2 over 3 y all to the power 5. Okay, now we cannot multiply x with y. Cannot multiply because the base is different. So we can divide x to the power 5 over 3 over x to the power 2 over 3. So we have x 5 over 3 minus the exponent in denominator 2 over 3. The same in the y to the power 4 minus 1 all to the power 5. Okay, now we have x after subtract, we have 3 over 3. This is equal 1, and y equal 4 minus 1 equal 3. Okay, and this is equal x to the power 5 multiply y to the power 3 all to the power 5. Distribute the exponent on x and y. So we have x to the power 5 and y to the power 50. Okay, another example. If we have radical x multiply by radical x multiply by 8 over 2x all to the power 4. This equal 8 over 2, this equal 4. And we have x to the power half over x all to the power 4. This equal 4x to the power negative half. Why negative half? This is 1. Half minus 1, 1 over 2 minus 1 equal minus 1 over 2. We can distribute the 4 exponent on the 4. So we have 4 to the power 4 multiply x to the power minus 1 over 2 all to the power 4. Now 4 to the power 4 equal 256 and x to the power minus 1 over 2 multiply 4. Multiply, this is because exponent to exponent. So we have 256 multiply x to the power minus 2. This equal 1 over 256 x squared or 256 over x squared. Which one? رقية second. غيره. غير رقية. مهند second. سارة second. لينا second. الثانية أكيد الثانية، بس أغلب الطلاب إنه لما ينزل إكس بنزل معها الرقم اللي جنبها. هنا يعني كثير أثناء التصحيح بشوف هذا الخطأ. Just put it negative exponent in the denominators without the coefficient. Coefficient is still in the numerators. So this is incorrect. This is the correct. Okay. 256 over x square. مين اللي كان يسأل؟ أتوقع يعني حطيت مثالين إضافيات. This is clear now. Who asked me?
أنا
الآن واضح؟
Yes, thank you.
Welcome. طيب هنا نشوف هنا. Look at this. If we have the exponent and the power even, we can remove 6 with 6. But look at this. This is equal what? Not y. This is absolute value of y. But if we have odd root, index root, and the exponent, we can remove 5 with the root, but this is equal y without absolute value. Why? Because this is the odd exponent with the odd index. If we have the exponent of x greater than the root, look at this, 13. 13. This is, we can put it x as 2 multiply of x's with different power. Now the multiplication of 3, put it alone. For example, x to the power 12. This is 12. We can divide on the 3 and put it x alone. X to the power 1 with 12. This is equal 13. Okay, so x equal 13. We put it 2x multiplied together. One of them 12 and 1 to the power 1. Why we not put it 10 with 3? For example, 10 with 3, okay, 3 can divide by 3. This is 3 can divide by 3. By this is 3, the index. But 10, this is still greater than 3. Why do not put it the 11 with 2? Because 11 and 2 not divide by 3. Okay. Now, so we separate the x to the power 13 to x to the power 12 multiply x. Now, put it the x, each x in the radical alone, like this, sorry. Wait. Like this. Now, any x to the power m with radical n, this is equal m over n, m over n. So 12 divided 3, this is equal 4, x to the power 4. And x with index, with the radical index 3 is still inside the radical. Now, look at this. We can put it this one in one radical, like this. 2 over 16, this is 1 over 8. We can remove 2 with 16, this is equal 8. 2 divide 2, 16 divide 2. And x to the power 4 over x, this is x to the power 3. Now, distribute the radical, this one, distribute the radical with index 3 on the numerator and denominators. This equal 3 over 3, so we can remove 3 with 3 equal x, and the cube roots of 8 equal 2. So we have x over 2. Radical inside radical, multiply 3 with 5, this is equal 15. Radical with index 15. Last example today, look at this, example 5. We can put it, the two radical, this is simplified. All of this exercise, this is simplified. Okay, put it in the one radical with index 3. Now, from 4, we can put it 8 multiply 3. Why 8 multiply 3? Because 8, this is have the cube roots or radical with index 3. Okay, and we can remove 3 with 3 with x. After multiply x squared with x, we have x to the power 3. X to the power 3 with radical with index 3, remove 3 with 3. So we have x and we have 8. So now look at this. The radical here equal 8 multiply 3 multiply x to the power 3. Put it 8 and 3 and x to the power 3. This equal 2 and 3 with 3, this equal x, and this is still as it is without change. So we have 2x multiply with cube roots of 3. Also we have here, this is the last, sorry, this is 2. The last 3 cannot put it outside the radical square roots, but 12 we can put it 4 multiply 3, 4 outside 2. So we have here also x to the power 3. X to the power 3 we can put it x multiply x square. So x square outside x and inside x 3x. So look at this. This one, this is radical 3 multiply radical x to the power 3. X to the power 3, put it as x square multiply x. So we have 3 with x and put it x, this one outside because we have 2 over 2. So we have this one multiply 4. Now we have x here and the 12, this is already mentioned, this is 4 multiply 3. The radical of 4 equal 2, so put it outside 2 and inside 3x. Also we have 3x here. So we have 3x, 3x, 3x outside 5x, 2x, 4x. Now 4 plus 2 equal 6 minus 5 equal 1. So we have 1x radical 3x. Okay. Again, here, the first one we have 4 multiply by radical 3x squared. This equal to the power 3. Here we have 4 and we have 3. We can put it x squared multiply x. Why? Because the power inside the roots greater than the index. The index 2, the index of the radical 2. Inside the radical we have exponent 3. So we can separate as it is. Now this equal, we can put it x square outside because the radical of x square جذر الاكس تربيع هذا x مع قيم مطلقة. إذا في عندنا 2x راديكال 3x. طلعنا فقط الاكس سكوير. هذا أول واحد. هي هذا أول واحد. أوكي عندي عفوا 4 4. طلعنا الاكس multiply by 4. نيجي للثاني. الثاني اللي هو هذا. في عندي x radical 12x. This equal x 12. This is 4 multiply 3x. So we have radical 4 2. So put it 4 radical 4 outside. Radical 4 2. صار 2x radical 3x. أي 2x radical 3x. وهذه نزلت كما هي بدون أي تعديل. Inside the roots we have 3x 3x 3x. Outside the root we have x x x. So addition and subtract the numbers only. 4 plus 2 6 minus 5 1. So we have 1, but we can not write the 1. Okay, any question? Any question? يا فيصل حكيت هذا الكلام أكثر من مرة، حتى الآن نفس الترم الماضي. لو أنت حاضر معنا بالبداية ذكرته أكثر من مرة. هو نفس النظام الماضي، لكن ممكن يكون يتعدل يعني. أي سؤال آخر بالنسبة لمحاضرة اليوم؟ التحضير أوتوماتيكي، يعني اللي بيدخل بيعرف متى طلع ومتى دخل وإلى آخره. التحضير أوتوماتيكي بيتسجل بقائمة معينة لوحدها. للأسف ما سجلت المحاضرة، لأني ذكرت أنه أكثر من مرة سجلت ما نفع، وهذه المرة أيضا للأسف نفس الشيء. لغاية الآن ما أجاني رد مع أني وقفت. ما بعرف، أحيانا ما تظبط. طيب أنت سجلتها، ما في مانع تشاركها مع الطلبة، ما في مانع، ما عندك أي مشكلة. طيب خلص، اللي بده يغادر عليه علامات. برضو ذكرنا هذا الشيء. ألوية، إذا ذكرت اسمك صح، ألوية. لسه ما عليها درجات، فقط ذكرنا التجميع. 20 30 وفاينل 50. علوية. أوكي. طيب نشكركم جميعا، إن شاء الله نلقاكم على خير إن شاء الله في المحاضرة القادمة. طبعا هي مش الأسبوع القادم، اللي بعده. نلقاكم على خير بإذن الله في المحاضرة القادمة، والسلام عليكم ورحمة الله وبركاته.